Did you know that elements, all the elements in the periodic table, they have some variation in their properties? And that's why that was why we are treating this topic, says periodicity of elements. Periodicity of elements. This periodicity, when we talk about this periodicity, what do we really mean? What do we mean by that? What we mean by this periodicity is just that the variation is talking about the the variation in physical and chemical properties of the uh, of an atom due to changes in the what in the electronic configuration of their electrons. Due to the changes in electronic configuration, there tends to be what variation, and if you arrange them like in the periodic table which we have done before, if you look at those you find out the way they are arranged in a kind of a block horizontally, vertically, there's always changes in there. So today we're going to be looking at some of the features, some of the variations that is very common in the periodic table among the elements. Now when we move at, the first one we're going to be talking about here, we're going to be looking at the atomic size, ionization energy, and electronegativity. Now, we all know that the metallic property, like what we have already discussed in our previous class, we are meant to understand that the metallic property increase as you move towards the what, towards the right, and non-metallic property increase as you move what towards the sorry towards the when you move towards the left, the metallic property increase. As you move towards the right, the non-metallic property increases. So that one has been dealt with. So today we'll be looking at this other one: atomic size, ionic energy, and ionization energy and electronegativity. Now, there are some features, some of the factors that affect this atomic size is there are two factors that affect it. Note very well, there are two factors which I have already written down here. Factors that affect is the nuclear charge and screening effect or shedding effects. Now, what are these things all about? The nuclear charge has to do with the force, attractive force, because each of the nucleus attract electron to itself. Now, because in the periodic table, in each of the periods, for period one, I mean period two, let's start from period two, they have two shells. Period three has what? Three shells. So as electrons is being added to the same number of shell, the attractive force tend to increase. Now, that result to what we call the result to decrease in a what? Atomic size. Now, what is this atomic size? Atomic size has to do with the distance between two electrons. So the distance between them give us the atomic size. This distance now is what we call the atomic size, because we cannot really, because of the small nature of them, we cannot really measure it. And rather, what we do is to compare the two electrons. So here, as as the electron is being added continuously across this period in the same number of shell, what happens is that the attractive force increase. That is the nuclear charge increase. There's increase in the nuclear charge because of the electron being added in the same number of shells, drawing them closer to each other, reducing the what atomic size. As the electrons are being drawn together, it reduces the atomic size. That means across from left to right, atomic size increases. So when we come down the group, let's say group one, we're talking about group one now. This group one, when you come to the group one, atomic size tends to what? Increase down the group, because each of them there is continuous change in the number of shells. The number of shells increases here. Here we have two shells, here we have three, the next one we have four. So for this reason, it tends to reduce the effect of the nuclear charge. And in this other side, down the group, the effect of the screening effect or the shedding effect tends to increase. But rather in the period, across the period, the shedding effect has no, the screening effect or shedding effect has no really is very, very insignificant when you come across here, across the period, but down the group, its effect is high. Now, what is this screening effect? You know that each of these electrons, since they are the same charge, they have the same charges, they tend to repel each other. Like we already know, negative, negative repel each other, and then positive, positive repel each other. For that reason, because they are all negatively charged, they tend to repel each other. So the effect increases here, making the atomic size to making them to separate from each other more due to repulsive force that is existing here. That repulsive force made them to separate from each other, increasing thereby increasing the what atomic size. Now we come to the ionization energy. Ionization energy is that the energy required to uh, ionization energy to release electron, to form what? Ion. When during a chemical reaction, electron, the energy required to release, to knock off electron from an atom of an element tends to be what? It tends to increase. It increases across the period from what? Left to what? Right. And what? Decreases down the group. It increases from left to what? Right in the period, and then decreases down the group. Now, why is it so? The reason is just because of the same reason. This force of the nuclear charge, the force of attraction of the nucleus tends to be higher as you move across the period, and then this force is affected by the number of shells, increase in number of shells, making these electrons to be added in the next shells, no more in one single cell. Like what you have in the period, in each of the period, like I've already explained before, in each of the period, you find out that electrons are added to the same number of shells across the period. Then the force of attraction increases, then reducing the effect of screening. Or rather, when you go down the group, because of the number of different in number of shells, from here to we have 2, 3, 4, due to increase in number of shells, that makes it a kind of increase the effect of the screening effect, and also reducing the nuclear attraction, the attraction of the nucleus or the nuclear charge to the electrons, drawing them to this itself, to the center of the of the atom. Do you understand? So this is one of the ways. This is another thing that happens there. And the last one, electronegativity. Electronegativity is the ability of an atom to form negative ion. That's how I used to, whenever I want to remember it, you know, ability of atom to form negative what? Ion, to attract electron to itself to form what? Negative ion. So in this case, when we move across the period, electronegativity will increase across the period from what? Left to what? Right. Electronegativity increases, and then down the group, electronegativity decreases. Now, one of the hints I want to give you, or a trick of remembering this, is that most of the things is that anything that increases across the period decreases down the group. Anything that increases across the period decreases down the group. This is because of the nature of, because of these two basic things that we notice that always affects what happens: the screening effect and the nuclear charge, or the attractive force of the nucleus drawing electron to itself. So from here now we're going to be that marks the end of this class. And if you have any question, you can leave it at in the comment section there, and then I will attend to you. If you're joining for the first time, please try it and press the subscription button there, and don't forget to share and like. Let me hear. I want to hear from you. If there's anything you want to ask, any question, anything you think I should know, just leave it in the comment section. Thank you so much.